the Cartesian Bear, and I'm stuck in the graphing methods of yesteryear. It would make me very happy to become a polar bear, but it seems too complicated. What? You do not know why I would want to become one? Well, as a Cartesian bear, when I want to move from point A to point B, I can only move an X and Y. And X and Y and X and Y and X and Y. It makes me dizzy. I throw up. I want to be able to choose my direction and go in it. That would make me throw up less. I guess being a polar bear isn't too hard to understand. It's all about looking at a right triangle. Convenient. The way I think about point B is in terms of X and Y, which is why I'm a Cartesian bear. Point B is simply 4 units to the right and 3 units up. I call this point 43, and my notation is in XY. But how would a polar bear think of point B? Polar bears think in distance and direction, which makes a lot of sense. Point B is a certain distance away, r. When you're facing a certain direction, theta. How in the world can I find the distance r? Well, that's right. It's a right triangle. That's easy. A squared plus b squared equals c squared, or x squared plus y squared equals r squared. That must mean that r equals 5. So now I know that point B is 5 units away from the origin, but what direction, theta, do I need to face? But how can I figure out the angle theta? Well, that's right. It's a triangle. If you remember some ideas from trigonometry, you'll see the tangent of theta equals 3/4, or y over x. So now we know this point is 5, 0.67, and the notation is in r, theta. Well, I'm exhausted from all that geometry and trigonometry. Let's pause for a moment and see what equations we've learned from this. Pause. Welcome back. I can see you learned some important polar equations because my fur is a lighter shade of brown. I'm becoming more like a polar bear, but I still have a lot to learn before I make the full transformation. So one day I was thinking, there are a lot of ways to get from point A to B. So I know there are 2 pi radians in a circle, so if I have an angle here that is theta, I can face theta, theta plus 2 pi, or theta plus 4 pi radians, and be looking in the same direction. Another thing I realized is I can walk backwards. If I face point C and walk backwards, I'll end up at point B. This angle I need to face is on the opposite side of the circle. Think of it as halfway across. So half of 2 pi is pi. That means this angle is theta plus pi. If I add pi, 2 pi and 3 pi to theta, notice 2 pi will give me my original direction. If I walk backwards from there, I'll end up at point C. Point C is the wrong place. Point C is terrible. Point C stinks. Point C is where bears go to die. It would be pretty useful to have some simple formulas to help remember the different ways I can get to point B. So try it out. These shouldn't be too clawful. Clawful. Wow, I'm a full polar bear. The beauty of polar graphing is completely clear to me now. I'm ready for polar applications in calculus. But before I go, I want to share a very important message with you. Don't change who you are. Whether you're a poorly drawn cartoon bear or a fun and cool math student, the color of your fur doesn't matter. When you're true to who you are inside, you realize that life isn't unbearable. Bear.